Hi guys, welcome to our YouTube channel Engineers World. This is the third lecture of engineering mathematics. In this lecture we will discuss about what is the rank of a matrix, and we will solve some questions regarding the rank of a matrix. So let us first discuss what is rank of a matrix. Okay, first we will write what is the definition of rank of a matrix. Okay, a matrix is said to be of rank R. Okay, a matrix is said to be of rank R if, or we will say when, first one, it has at least one non-zero minor of order R. Okay, second one is these two conditions must be satisfied for having a rank R in any matrix, and the second condition is every minor of order higher than R vanishes. Okay, a matrix is said to be of rank R when it has at least one non-zero minor of order R, every minor of order higher than R vanishes. That means हम एक मैट्रिक्स को रैंक आर तभी कहेंगे जब उसका एक माइनर, एटलीस्ट कम से कम एक माइनर होना चाहिए जिसका ऑर्डर आर होगा. ओके, और वो नॉन जीरो के बराबर होना चाहिए. इन दैट केस इसको लेट्स टेक एग्जांपल हियर. लेट वी हैव अ मैट्रिक्स A is in a matrix which is 3x3 matrix having order 3x3. I am saying that its rank is 2. Okay, that rank is 2 for this A matrix. That means it has at least one 2x2 non-minor, 2x2 minor which is non-zero. Okay, and minors of order higher than 2x2, that is 3. Okay, that should be 0. That means if we are, let A is in the matrix 1 2 3 4 5 6 7 8 9. Okay, I am saying that its rank is that order is 3x3, but its rank of A is equal to 2. I don't know is it 2 or 3, that I don't know yet, but I am assuming that its rank is 2. That means it has one 2x2 minor. These are like these will be minors, or this will be one more minor, and there are 9 minors will be 2x2, and one will be a 3x3. That is the determinant of a matrix. So in that case, if rank is 2, that means it has at least one non-zero minor of order 2x2, and it is a minor of order higher than 2 or 0. That means vanishes. That means its determinant value will be 0, because it is higher order minor of greater than 2 will be of order 3x3. That is just a determinant of a matrix, that is equal to 0. Okay, so that is the basic definition of a rank of a matrix. It has at least one non-zero minor of order R, and every minor of order higher than R vanishes. Okay, and there is one more definition, or we can say in other words, maximum number of independent rows or column. Okay, the maximum number of independent rows or columns in a matrix is also known as a rank of a matrix. Okay, so this is basic definition. Now we will see some properties of a rank of matrix, then we will solve some questions to you will get an idea what is the rank of a matrix exactly by solving some numerical. Okay, first we will discuss some properties. First property is First one is saying that rank is defined for both square matrix and rectangular matrix. That means if A is any square matrix of order n, or we say n cross n, and B is one matrix having order n cross m. This is a rectangular matrix, this square matrix. So it is saying that rank is defined for both, for square as well as rectangular matrix. Okay, square will have any rank and rectangular will have also some rank. And let's take this one, rectangular matrix. Okay, rank of a rectangular matrix. Let I have any rectangular matrix A whose order is m cross n. Okay, it is maximum possible rank will be maximum possible rank, that is rank of A will be minimum of these two m comma n. Okay, that means if A is in a matrix 1 2 3 4 5 6 7 8 9 10 11 12, this is of order 3 cross 4, it is maximum possible rank will be minimum of these two. Okay, so maximum possible rank in this case will be 3. Okay, because minimum of these two is 3. Or we can say, in other words we can say its rank will be always, rank of this A matrix will always less or equal to 3. Or in general words, rank of this B A matrix will always less or equal to minimum of m comma n. This is a correct statement actually. Rank of a rectangular matrix will always be less or equal to minimum of these two, number of rows or number of columns, which one is less, so rank would be according to that. Okay, this is the first property. Coming to the second property. Second property is saying that if A is in a null matrix, we know what is a null matrix, its rank is always equal to 0. For all A is a null matrix. What is null matrix? Having each element is a 0. Okay, so rank in that case is a 0. Third property is saying that for non-zero matrix, for any non-zero matrix, rank is always greater or equal to 1. That means rank is only equal to 0 in the case of null matrix, and in all other cases it is always greater or equal to 1. Okay, then fourth property is rank of a non-singular matrix. We know what is a singular matrix and non-singular matrix. Singular means determinant is equal to 0. Non-singular means determinant not equal to 0. So rank for a non-singular matrix, rank is always equal to order. Let's say that is n. Okay, that means if A is any matrix, any square matrix of order n cross n, but it is non-singular matrix, its rank is always equal to order of a matrix. Okay, coming to the fifth property. Fifth one is saying, so there will be one more case for this, that's rank of a singular matrix. singular matrix. That is, if determinant is equal to 0, in that case rank is always less than order of a matrix. Okay, if now this is A is any matrix which is a singular matrix, it is determinant is equal to 0, in that case rank is less than order. Okay, I hope this is clear to you. And there are some more properties, quickly cover them. And 6 properties. Let us say if A and B are two equivalent matrix, in that case rank of A is equal to rank of B. Rank of equivalent matrix is always same. I hope you know what is equivalent matrix. Like if A is any matrix, okay, this is any matrix A, and you know when we are doing some elementary transformation like that, if we are changing the rows like this, R1 gives R1 minus 3 times R2, these things, and we get one matrix here which will be those entries, like elements will be somehow different in that case by doing some elementary operations. So these two matrices will be equivalent matrix. Okay, these are known as equivalent matrix. Okay, and one more property is that 7th property, rank of AB. A is one matrix, B is one more matrix. We are multiplying those matrices and finding the rank of those matrices will always be less or equal to minimum of rank of A comma rank of B. That means if I know rank of A is any matrix, I know its rank, that's 2, and B is one more matrix, its rank is 3, and I want to know what is the rank of AB. So in that case it will be rank for this matrix AB will always be less or equal to minimum of these two, that is 2, because minimum of these two is 2. Okay, one more property is 8th one, rank of AB is not equal to rank of B. Okay, if the multiplication is possible, that is defined, rank of AB will not be equal to rank of BA, but it may be, it is not always true. Sometimes it may be rank will be same, but it is not always true. Okay, sometimes it's not true. And one more property, 9th from actually important properties, is rank of A is equal to rank of A transpose. That means rank doesn't change by taking the transpose of a matrix. Okay, these were some basic properties of a rank. Now we will discuss some questions which have been asked in competitive exams like GATE, ESE. We will solve those. Here first I have a question with me. The question is find rank of matrix, rank of A. First one is A is a matrix which is equal to 6 0 4 4 minus 2 14 8 18 14 minus 14 0 minus 10. The first property which I discussed with you, that was rank for a rectangular matrix is always minimum of these two. So rank in this case, rank of A will be less or equal to 3. Okay, the first property which I discussed. Now I told you that two definitions for a rank of matrix. First is that two conditions must be satisfied, and the second one was maximum number of independent rows or column. Okay, So here we will do this question by doing some elementary transformation. Okay, if we clearly see here, if we apply this operation R3, we are doing elementary transformation on row 3. That means R3 gives R3 minus 2 times R1 plus R2. Okay, we will get a matrix as like this. First two rows will not change. 6, 0, 4, 4, minus 2, 14, 8, 15. So we are applying R3 minus 2 times R1 plus R2. R3 here is, R3 is 14 minus 2 times R1, that is 6, plus R2, that is plus, but it is minus 2, so we write this. So 14 minus 12 minus 2, so it is 0. So this element will be 0. Similarly, this element R3, that is minus 14 minus 2 times R1, that is 0, so it will be 0, plus 14 minus 14 plus 14, so this is also 0. R3, so it is 0, minus 2 times, so R1 minus 2 into 4, that is 8, plus R2, that is 8, minus 8 plus 8, so 0. This will also equal to 0. So there was a dependency between the rows of a rows of a matrix. Okay, there is a dependency. So we want to see what is that dependency. We are applying that kind of operation, elementary transformation on the matrix, and try to make this one row as a 0. If it is possible, it will become ultimately 0. So now there will be no dependency between these two rows. So there are number of independent rows in this case are 2. So rank is 2. Rank of A is 2, because number of independent rows are 2 in this case, R1 and R2. I hope this one is clear to you. Let us discuss one more question. It is saying that A is equal to matrix 4, 2, 1, 3, 6, 3, 4, 7, 2, 1, 0, 1. This is a 3 cross 4. In this case also rank will be less or equal to 3, because it can't be equal to 4, because minimum of 2 we know. So I hope you guys know what is the echelon form. Echelon form is that if any matrix is like A is a matrix A, B, C, D, E, F, G, H, I. This is a matrix. If we try to make these elements as a 0, okay, these elements as 0, we will get a like this: A, B, C, 0, E, F, 0, 0, I. This will be known as a echelon form. Okay, so we will try to find the rank. We are going to do some element transformation on this matrix and try to make it in an echelon form, so that we will come to know what are the number of independent rows or independent columns in this case. And number of independent rows is rank of a matrix. Okay, so if we apply operation like this, try to first in echelon form try to make this element as a 0 and this element as 0. If we apply this, R3 gives 2 times R3 minus R1, and R2 gives 4 times R2 minus 6 times R1. Try to make these two elements as 0. We will get matrix as like this: 4, 2, 1, 3. These two will be 0, because 2 times R3, 2 into 2, 4, minus R1, that is 4. So 4 minus 4, so this one will be 0. And similarly 4 times R2, 4 into 6 minus 6 into 4, so this one will always also 0. And rest of it, and this one 2 times R3. So 2 into 1, that is 2, minus R1, that is 2. So this one always also 0, and this one will be minus 1, minus 1. And so coming to this second row, 4 into 3, that is 12, minus 6 into, so this one also 0, and this one will be 10 and 10. So clearly there is a dependency between, we can see it, there is a dependency between, these two rows are proportional to each other. If we apply this operation now, R3 gives us 10 times R3 plus R2, we will get as A as like this, 4, 2, 1, 3, these two 0, 10, 10, and these all elements will be 0. So number of independent rows are 2, so rank of A is 2. Okay, just try to make, in first step, try to make these two elements as 0 by doing with the help of row 1. Okay, use row 1 to make this element, these two elements as 0, and then apply operation between these two and try to make these elements as 0. If it is possible, it will ultimately these will become 0, and if it is not possible, so rank will be equal to 3. Okay, I hope this is clear. Coming to one more question. So quickly we'll take one more question I have. Okay, A is a matrix like this, 1, 1, 1, 1, minus 1, 0, 1, 1, 1. Okay, we have to find rank of this matrix. Clearly you can see there is, these two rows are same. So if we apply operation as R3 gives R3 minus R1, we will get A is equal to 1, 1, 1, 1, minus 1, 0, 0, 0, 0. So number of independent rows 1 and 2, so rank is directly equal to 2. This question was asked in the GATE 2018 for 2 marks. It hardly took 30 seconds to solve, but you should know what is the basic concept of it behind the question. Okay, quickly we will take one more question. I had one more question, that is I think last one. So 1 minus 2 minus 1 minus 3 3 0 2 2 3 cross 3 matrix. So rank would be less or equal to 3. So if we apply this operation, R2 gives us R2 plus 3 times R1, and R3 gives us R3 plus, minus 2 times R1. I told you that try to make these two elements in first step as 0. So we will get A 1 minus 1. These two will be 0 because R2, that is minus 3 plus 3 times R1. So minus 3 plus 3 0, and similarly 2 minus 2 into 1, that is also 0. Okay, this will be R2, that's 3 plus 3 into minus 3, so minus 3, and this one also minus 3 because 3 into minus 3. Okay, and 6 and 6 because R3 is 2 minus 2 into 2, that is minus 2 into minus 2, that is plus 4 plus 4 plus 2, that is 6, and similarly 4 minus 2 into minus 1, so 6. Okay, there is clearly a dependency, and these two rows are proportional to each other. Okay, so if we apply this operation, R3 gives us R3 plus 2 times R2, we will get A as like this, 1 minus 2 -1 0 -3 -3 0 0 0. Okay, so number of independent rows 2, so rank of this matrix is also 2. Okay, I hope this is clear to you. I just try to, if I have one more question with me. No, those are the questions with me. If you have any doubt about this, let us know in the comment section and we'll be happy to answer it. Okay, so just remember this, what is the basic definition of a rank of a matrix? Okay, number of maximum number of independent rows or columns, and if you are solving any question, try to make that in echelon form. Try to make those like if it's a 3x3 matrix, elements first, these elements. Okay, these two elements in first step, try to make them 0 with the help of this row, and in the second, apply operation between these two rows and try to make these elements as 0. If rank has to be less than 3, in that case these two will ultimately become as 0 and we will get determinant value as 0. So rank will not equal to order of a matrix, rank will be less than that. Okay, okay, see you in the next video. Till now, if you find this video as helpful, share with your friends and please subscribe our channel Engineers World. Thanks for being here.